So let's calculate that. If you are calculating in your calculator, you need to either put the top in parentheses or do the calculation in 2 steps. So I can do it like this, or I can just do it in 2 steps. 22 minus 26.9, enter, divided by 2.6, enter. Okay. And recall, we're going to round these to 2 decimal places because that's what we have when we go look in our table. So negative 1.88 is my z-score. Now I'm going to rewrite the probability statement with z. So what this is equivalent to saying, if I'm looking for the probability that x is less than 22, that's equivalent to saying I'm looking for the probability that z is less than negative 1.88. And so that's what I'm going to go take to my table. Make sure I'm on the negative side. I'll draw my picture first. 0 in the middle, so negative 1.88. And I want less than negative 1.88, so I'm looking for this. That's great. This is a less than. I just get my value from the table, and that's it. 1.88, 0.0301. So if you wanted to answer this in words, since it's an application now, the probability that a single 24-year-old month boy would weigh less than 22 pounds is 3.01%. So it's pretty unlikely, right? Less than 5%. It's a small chance. Find the probability that a randomly selected 24-month-old boy weighs more than 25 pounds. So the probability statement with x is that I'm looking for when x is greater than 25. Now I need to find the z that matches up with the x value of 25. So I turn the 25 into a z. So x is 25 minus 26.9 over 2.6. And I get negative 0.73 for my z-score. So the probability statement with z is that I'm looking for when z is greater than negative 0.73. So you're just swapping out the x for the z, the x value for the z-score, but the inequality stays the same. So when I draw my picture, I think these should always be steeper than I draw them. Sometimes they look really flat, but they're really pretty steep. So that's a good one. There's 0. There's negative 0.73, but I want greater than. So greater than, this is a pretty big chunk I've shaded in. This is a greater than, so when I go to the table, I'm going to do 1 minus my table value. Oh, sorry, that's the 0 from the middle. And that's negative 0.73. So I am looking on my negative side. Negative 0.73 is 0.2327. Oh, I don't really want to box that in, do I? 1 minus 0.2327 is 0.7673. That's what I wanted to box in. And now, big shock, we've got a between question. What's the percentage of 24-month-old boys who weigh between 21 and 26 pounds? So 21 is the low value. 26 is the high value. These are x values. This is data that actually is coming from our question. We're going to turn it into one with z values, right? But we need to turn these x's into z's. So we've got to find the z-score for each of these. 21 minus 26.9 over 2.6 and 26 minus 26.9 over 2.6. So negative 2.27 and negative 0.35. So the 21 gave us the negative 2.27, so that goes here. and the 26 gave us the negative 0.35. So when we draw our picture, we've got two z-scores that are both negative. So here's z, 0. So negative 0.35 is pretty close to 0. Negative 2.27 is back there, and we're looking for this area in between. So we're going to look up the two table values and subtract them. So first look up the negative 0.35. 0.3632. Then look up the negative 2.27. 0.0116. Sorry. Yeah, that's right. 0.116. And subtract those. So it's not asking you to, but again, the way we could interpret this is we could say that 35% of 2-year-old boys weigh somewhere between 21 and 26 pounds. Here's another very similar question. So it would be great if you want to pause the video here and try to work this one out yourself. And then when you're ready to check your answers, come back to the video. There's our two probability statements and our z-scores for the picture. Z is between negative 0.5 and positive 1.5. Our two table values are 0.9332 and 0.3085. So our answer is 0.6247. Z is a positive 1.1, and I want the area to the right of that. So 1 minus the table value of 0.8643 gives a final answer of 0.1357. Z is a positive 0.5, and we're looking for the area to the left of it. So we just get the table value, gives us the answer. So I bet some of you are really wondering, are we really having to use this paper table? We can do this in the calculator, okay? So to find the value of a normal random variable, you're basically working backwards. This is the part we're going to do in the calculator first. It's kind of the opposite direction of what we've just been doing. So they're going to give us the probability, which is the area of the shaded region, and they want us to find the z-score. The way we can do this in the calculator is by using the inverse norm feature. We can also use table 7. So that's table 5 we were working with. If we flip further, we should also have table 7. And this is a different one. We're going to look at this a bit later in the class, But if you go, this is a T distribution, not a normal bell curve. It kind of looks like it, but it's a little bit different. We'll talk about that later. If you go to the bottom, though, there is a 0. And so that can be helpful for you. So for some of the common areas that they give you in here, then here are some of your z-scores. Okay? But we're going to use the calculator for now. So you need to figure out the area less than z. So they might have talked about the top 10%. Then the area less than z would be the bottom 90%. So you might have to do a little translation there because your calculator and that table are both programmed and set up based on how much area is to the left of z. So we're going to get to this option in the second variables. Second variables gets us into the distribution. And you'll see it's here, it's this third option. Number 3, INVNORM. So we'll press that. And then we'll type in the area less than z and press enter. So we could actually practice one of these that we did right here. This garbage question, less than 29 pounds per month. That was a z area less than 0.5. So if we type in our 0.6915 as our area, then it should come up with that 0.5 as the z. Okay, so it's going backwards. So the table says if you know your z, you can find your area. Inverse norm says if you know your area, you can find your z. So it's inverse because it's going the other direction. So let's find a z-score such that the area under the standard normal curve to its left is 0.1. Okay, so we're going to start by drawing the picture. So, a little picture here. We are looking for a z so that the area to its left is 0.1. So 0.1 is like 10%. So 10% of your curve is shaded, okay? I'm not perfect at estimating, but it's like a little tail. So again, we're going to start putting the areas on the top of the curve, and the bottom is reserved for the z's. So the question is, what's this z? Okay, so we're going to use inverse norm to find that. Now, it's good if you can, from this picture, predict should your z value be positive or negative. Here's 0 in the middle, so it should be negative. Okay, so z is going to be inverse norm of 0.10. So you'll see my fancy calculator did all this stuff, and it was asking me, you know, left, right, and all that stuff. So I think this one you can actually work around. If you want the area to the right, you can choose right. But some calculators just work on the left, so I'm going to work with that. If you just type in the value, you really don't need any of this other stuff. If I just say inverse norm of 0.10, that's totally fine. Okay, and it tells me that the z is negative 1.28. So that's what I was looking for. If I have a z of negative 1.28, then 10% of the data will be to the left of that. And then that implies, it's unsaid, but it implies that 90% of the data will be to the right of that. Find the z-score such that the area under the standard normal curve to its right is 0.25. So this time the area is to the right, and it's a little bit bigger area. So the area is 0.25. So now, might want to use a different color. How much area is this? Well, the area has to add up to 1. So if that's 0.25, this is 0.75. So your z is going to be inverse norm of 0.75. Should this z be positive or negative? Well, if there's the 0, this z is to the right, so it should be positive. So when I do inverse norm of 0.75, I get positive 0.67. So that is my z. So the picture can really help you kind of make these basic initial predictions so that when you're using your technology or you're using a table, you kind of have in mind what the answer should be. So if you don't get that, you can take a closer look and you can see where your problem is. Now, if you by chance just entered inverse norm of 0.25, maybe you weren't reading the question correctly, what would happen? If you put in inverse norm of 0.25, look what you get. You get negative 0.67. So that would be kind of the reflection over here. So it does matter, but if you wanted to take a shortcut, if you can keep track of all this in your mind, then you could do inverse norm of 0.25, but know that you need the positive z because this z is to the right of the mean. So then you could do this in your calculator, but you'd have to change the sign. So it's kind of up to you. As we move on through the text, we are going to do that shortcut a little bit. So let's make a note of that. Inverse norm of 0.25, but make the sign plus minus match the z in your picture. So on the upcoming quizzes and tests, it really is going to be important that you draw a picture. You will get some points for the probability statements, some points for the pictures, some points for the final answers. So you really don't want to be skipping those pictures. I mean, look at mine. They're really ugly some of the time, but just draw yourself a sketch so you have something there. So then the calculator would give you negative 0.67, but you would say, oh, it needs to be positive, so it's really 0.67. So either of those approaches is fine with me. Find the z-scores that separate the middle 99% of the distribution from the area and the tails of the standard normal distribution. So this time, they're saying we've got almost everybody in here. Everybody in here is 99% of everybody. So there's just a little bit here, a little bit here. Well, how much is that little bit? Well, if you take 99% away from 100%, you have 1%, right? So in terms of decimals, that's 0.01. But this is the middle 99%, so this 0.01 is split up into the two tails. So divide by 2 and you get 0.005. So right here is 0.005 and right here is 0.005. If you want, you can make those a different color. Doesn't really matter which part is shaded and which part is empty, because really in these questions on this page, I'm really just trying to find out what are these z's. Okay? They're not asking me a probability, they're asking me what are these z's. So you've got two z's, and because this is the middle 99% and the tails have the same amount, there's a lot of symmetry here. So these z's are the same thing, just this one's positive and that one's negative. So how are we going to use inverse norm? If you just do inverse norm of 0.99, you're not going to get the correct answer. If I look at this z right here, so let's say the positive z, it's going to be inverse norm of all the area to the left of it. So the area to the left of it is the 0.99 plus the 0.005. So that would be inverse norm of 0.995. Okay, so you've got to put the middle 99% plus that other 0.5% back there together to get this one. So that is 2.58. And so then the other one's going to be negative 2.58. Now the negative z would have been a lot easier to start with that one, right? Because how much area is to the left of this negative z right here? Just the little red tail, just the 0.005. So if you'd done that one first, you'd have a little easier work. That one gives you negative 2.58. So those are our two z's. You can find either one first, and then just know that the other one is going to be the opposite. This question is kind of leading us into some future terminology that we're going to use. So this is z sub alpha. So when we are asked to find the value of z sub alpha, it's always going to be a positive because they are referring to the fact that the area to the right of z is alpha. So when they say something like this, find the value of z sub 0.025, what they're telling you is that this is the area in the right tail. Okay? and they want you to find the z. Okay, so alpha is the area in the right tail. So z alpha is the z value, or the z score, where the tail, well, where the right tail has area alpha. So for a picture, it's a little right tail. The area of the tail is 0.025, and we want the z. So we're doing this inverse operation now. Instead of knowing the z and looking up in the table to find the area, we know the area, and we have to use inverse norm to find the tail. So if you wanted, you could find, like we did up here in the second one, you could figure out how much space is over here. But I'm already lazy. So I'm going to say it's inverse norm of 0.025, but I'm making a note to myself to use the correct sign, plus or minus. So from my picture, I should be able to tell that z needs to be a positive number. When I input this into the calculator, it's going to give me the -1, but it's going to be symmetric. It's going to be the one over there. So the value is going to be correct, but I just need to use the correct sign. So inverse norm, 0.025. It gives me -1.96, but I know it needs to be positive. So it's going to be positive 1.96, okay? Because really I was kind of lazy in what I told the calculator, so I have to make this adjustment. Okay, last page. This is one more additional new kind of question. There's a lot in 7.2. Take your time, practice, ask questions. Got quite a few things going on. And what we do in 7.2 is really going to stick with us for the rest of the semester up through chapter 11. So the sooner you can get a grasp on it and really understand what's going on, the more that's going to help you for the rest of the whole semester. In a couple of these application problems where we're using the inverse norm, they don't want to just know the z-score. They want to know what that translates to in a real world application. So that's the x. So at some point, we're going to have to solve this z-score formula for x. So we're trying to get this x by itself. I don't like this divided by sigma, so let's multiply both sides by sigma. So then sigma z equals x minus mu. It's like the most algebra we're doing all semester. And then I want to get the x by itself, so add the mu. So x is going to be sigma times z plus mu. You don't even have to do that again. You can just have that formula now in terms of x as a reference. Okay, so if you've ever heard of Mensa, it's like this high IQ society thing. What IQ score do you need to join? So you need to get a score on you need to score on their IQ test at the 98th percentile or higher. So you need to be as high performing or more high performing than 98% of the people, right? We talked about percentile in, I don't know, chapter 4 maybe, something like that. We also know our mu and our standard deviation. It's kind of, might be hard to know where to start. I am always going to recommend start with a picture. So your percentile is what's going to help you get something on your picture. So here is, so we know that if this is representing all the people who took this IQ test, 98% of them are lower than you. So what percent are higher than you? 2, okay? So that's what the 98th percentile means. What I want to know is what's this z? Now that's not going to be my final answer. My final answer is going to need to be a score on the IQ test. But this is what I need to find next. Okay? So here's 0 in the middle. So this z needs to be positive. It is to the right of the 0. So inverse norm of, you could really do either one. The correct way to do it is inverse norm of the 0.98 Or you could do inverse norm of the 0.02, but then it's going to give you the negative value, and you need to make it positive because your z is to the right of 0. So 0.98 gives me a z-score of 2.05. Okay, maybe let's do this. We'll say, or inverse norm of 0.02, but then make it positive. So this is your z, but they want to know what IQ score do you need, not what z-score. So you're going to put your z into this formula with your sigma of 16 and your mu of 100. So x, the IQ score, is going to be sigma times z plus mu. So it is an IQ score of 132.8 that you need to get into Mensa. Okay. And here's one more. So this one, when it talked about the percentile, remember the 98 percentile means 98% below you. Okay. This one is worded a little bit differently. Same kind of question, but the wording is a little different. And again, moving forward, just all these questions, there's just a lot of wording. It's a lot of, what can we pick out from each question? What refers to which variable? How do we put it all together? So in this one, to qualify for a police academy, candidates must score in the top 10% on a general abilities test. So now instead of referring to the percentile, where you have the amount below you, they're referring to 10% above you. Again, if you wanted, I don't really care which part of these is shaded, but this would then refer to the 90% of people that performed below you, because you were the top 10%. So we want to find this z. So they must score in the top 10% on a general abilities test. This particular test has an average of 200 and a standard deviation of 20. What is the lowest possible score they need to qualify? Assume the test scores are normally distributed. Okay, that's why we're able to do all this, because the data is normal. So we're going to do inverse norm of, again, if you just put in the 0.10, it's going to give you a negative. So you're going to make it positive. Since it's not too much work to draw this whole picture,